reveal new information about vitamin K2. So yeah, looking forward to hear it. Over to you.
Thank you very much, Anna.
Thank you, Anna.
Yeah, you're right. I mean, this is quite a relatively new subject. I think you could say, or we could say, that nutrition in general is still quite a young science, but it's just amazing sometimes how much stuff is unfolding. And when we talk about nutrition, I mean, we have to talk holistically, and I always try and put sort of supplementation in particular in its own place, because we have to think about lots of other things as well. But and in terms of nutrients, when we're talking about nutrients, we don't really want to consider them on their own. And it would be a bit of a nonsense to consider them on their own in some ways, because our body is so complex. We've got thousands of enzymatic reactions going on all the time, which are dependent on lots of different amino acids and vitamins and phytochemicals and minerals and all of that sort of stuff, that to single out a single nutrient seems a bit ridiculous. But in this case, I think because it's a fairly little known nutrient, a little known vitamin, really, that it's important that we do acknowledge its importance. And it turns out, through the research that we've been doing, I mean, it turns out that I think there's almost nothing bigger, and the significance of vitamin K2 and its place in our health cannot really be overstated. And I think we're going to hopefully try and make that clear over the next 6 or 7 hours. No, we're not going to go see but maybe the next, I don't know, 45 minutes or something. And so we've put together this presentation, gave us an excuse to misspell the word seKret, and that's about it. And the molecule you can see on the right, we don't know what it is. It's not vitamin K2 though, but anyway, so
yeah, I would say that judging on a past experience, it takes about 30 or 40 years for research to come into sort of mainstream advice. But we feel that this is so important that we can't afford to wait that long before we start implementing this knowledge.
Yeah, in terms of sort of K2 being incorporated in USANA's core formula, for those of you who are associated with USANA, it's been in for quite a long time. But a few years ago, they did release it as a separate thing, as a kind of booster. And given that they're always updating in response to the science as it's unfolding, I would anticipate the next formula, the next time they redo it, maybe the levels of K2 will go up, but we have quite a decent level already. But anyway, we're going to sort of detail all that a little bit as we go through. Once the computer unsticks, which is, is always... Angela, can you just do a little dance or something?
Let me try that.
The mouse. Here we go. Okay, so hopefully it won't stick anymore. So as it says, they're really, really important. You know, neither of us are doctors. As Anna said, my background is in biology. I've been around nutrition and health coaching for a couple of decades, but I'm not a doctor, and this is not, and nor is Angela, and this is not intended to be medical advice. We're not trying to diagnose or treat stuff. All we're trying to do really is to sort of tell you what we found, and hope you find it interesting. I think it's vital information. I think if you ignore us, you'll die immediately, but no, anyway. But anyway, yeah, this it is important information, but everybody is individual, and we're not trying to act as medics here. So when I do these talks, I always like to put us, and when I'm talking about us, I mean 21st century us, in our perspective. And I think this slide is relevant to this as well, because when we look at the reactions going on in the body, if we go back to sort of how long we've been around as humans, you know, Homo erectus and Homo sapiens and all these different hominids that have risen up, we've for most of that time, for almost all of that time, we've been hunters and gatherers. So we've been chasing down food and digging it up and picking it off trees, and et cetera, et cetera. And if we go back further than that, some of the reactions, in fact, that K2 is involved in with the mitochondria, they go back over 1 billion years. So we're not just talking about humans, we're not even just talking about mammals here. We're talking about bacteria, and the reactions that were happening in the bacteria are still happening in our mitochondria now. So,
and with our bacteria as well.
And with our bacteria, indeed. So, and if we sort of wind the clock forward a little bit, we have been agriculturists for a bit. We've domesticated cattle and we've grown wheat and stuff. And then we had the Industrial Revolution. And in a nutshell, that means we can get a ton of energy out of food very efficiently. And then we started in the last 50, 60, 70 years mainly to invent foods. And this was, look back at sort of the use of hydrogenated vegetable oils from about 1912, so about a century, let's say. And we've started to, we've altered our whole food chain. And now in the UK, 50.7% of our diet comes from invented foods. They're ultra high processed food-like substances. They're not foods. So it's important to sort of view in that context. And as we go through, we'll tell you sort of how relevant the K2 story is to this as well.
Yeah, it's interesting because our cells have evolved over millennia to recognize certain substances from the food that we've evolved alongside, and to do things with those substances. But now we're putting substances in the body that it just doesn't recognize. The cells and the receptors on the cells just don't recognize those things, and they treat them as toxins and puts enormous pressure on the cells.
Yeah, and what's the upshot of that? Sorry, didn't me. I was going to edit that bit. So the upshot of that bit is that we've got all these diseases that were at low levels until about a century ago, and now are just sort of all on a graph heading north, pretty much. Heart disease, cancer, Alzheimer's, diabetes, all these things, osteoporosis, they're all on the rise and fairly unchecked, really. So we're just going to go into sort of a little bit of introduction about what the K vitamins are. And this is what I learned at school. And as I said on my introductory video, I was on a genetics course recently and had a nutritionist there. It was full of informed people, a lot of nutritionists there. And the question came up about vitamin K. And this woman said, well, it's dark leafy green vegetables and it's responsible for blood clotting. And that's all. And I'm going like, what, really? So even amongst the profession, people are still thinking in those terms. Where do you get vitamin K from? Oh, it's great if you're a vegan, because then you're eating tons of this stuff and you get loads of K1, and that will stop you bleeding to death. And that is indeed true. It will stop you bleeding to death. But really, that's where the K1 story kind of ends. And vitamin K2, which is, they were kind of lumped together because they just didn't distinguish them at the beginning. But in fact, K2 has a lot more going for it, as you'll see. So
K2 is found in organ meats and fermented foods. This disgusting looking stuff here is called natto, and it's a fermented bean curd, fermented soybeans that is eaten in certain parts of Japan. So vitamin K2, they're all in the same family. They're all quinones. So K1 is known as phylloquinone and K2 is known as menaquinone. And you get various different forms of menaquinone depending on how many bits they've got in this tail. So from 4 upwards, there'll all be menaquinones with slightly different properties and found in different foods. So MK4 is found in animal fats from animals that have been fed on grass. That's really crucial to know that, because you don't get K2 in high amounts in animals that have been fed on grains. You get it to a small extent in egg yolks and in organ meats. Probably the highest organ content of K2 is in goose liver, but you also get it in the brains and the pancreas and all the bits that we don't like to eat. Then we've got anything from MK5 upwards, and particularly MK7 is the one we'll be focusing on today, because that's the one we tend to use. So these come from fermented foods, in particular fermented cheeses that are made in the Netherlands, Gouda, Jarlsberg. But then you've got these other fermented foods like natto, fermented soybeans, and in the picture, and sauerkraut has a little bit. So it's being made by bacteria, certain types of bacteria. It's also made in our guts by the bacteria in our guts. But what they're doing is making it so that they can use it as an energy source. So we're not really benefiting to a huge extent from that. Some K1 can be converted to K2, but K1 always goes first to the liver, where it's then used by proteins that make the blood clotting components in the blood. And if there's any left over from that after that, then that can be converted to K2. But that really depends on how much K1 we're getting in the diet. And most of us are not really getting enough to then convert to K2. So that leads on to the last bit, the last question, are we getting enough? And in most cases, the answer is no. Certainly, if you're a vegan or a vegetarian, you won't be getting enough. But for most of us, unless we're eating tons of cheese, or unless you're a Japanese eating natto, then you're not getting enough. And we're told we're not, it's not good for us to eat tons of cheese. We may dispute that, but you'd need to be having certainly huge amounts in your diet.
Yeah, natto is the absolute king of that. There's a huge amount of K2 in natto.
Yeah, so it's about 1,200 micrograms of K2 in natto per 100 grams of food. Gouda is about 70 micrograms. Egg yolks have about 5 micrograms. Grass-fed butter, butter from grass-fed cows is about 20 micrograms. So big discrepancies, but yeah, definitely. If you can stomach it. If you can
stomach it, because it's disgusting.
It's very, very smelly. I mean, I think if you've smelt stinking Bishop cheese, it's probably similar to that.
Times 50. Yeah. Okay. So the K2 story, it kind of goes back a long way, but people didn't realize what they were looking at the time. So this guy, there's an organization, the Western Price Organization. He was, he has a lot of followers, and he's kind of one of the, let's say, early nutritional scientists, really. He was a very interesting guy. He's a Canadian dentist, and he took it upon himself to sort of travel all around the world and visit indigenous populations and look at their diet and look at their health. And what he found from the health of a lot of these people was their health was excellent. They weren't suffering from the kind of diseases that Westerners were. And in particular, being a dentist, he was looking at their dental arch and their risk of cavities and their face symmetry and all those things. And what he found was that these indigenous cultures had fantastically symmetrical faces. They had plenty of room in their mouths for all their teeth. They didn't suffer cavities, although they didn't have toothpaste and toothbrushes, but nevertheless, there was something in their diet that was causing their teeth and other bits of their body, their bones and their arteries and everything else to be healthy. So he sort of coined this term Activator X. He couldn't really work out what was going on, but that's what he thought it was. And that story kind of got ignored for ages while we put K1 in the textbooks, really. And in 1943, there's this guy called Heinrich Damm, to give you a little bit of history, who was a Danish scientist, Danish biochemist, and he sort of discovered vitamin K. And then this other guy called Dosage, who sort of discovered the chemical structure. They won the Nobel Prize for that in 1943. So you may wonder why we've got basically vitamin A, lots of B vitamins, C, D, E. What happened to F, G, H, I, J is because the vitamin K comes from the German term coagulation. She can speak German, so I can't, but there you go. So that's where it comes from. So the K comes from that. and because it was first published in a German medical journal, really. So yeah, just moving on from, here's some pictures of, these are from Weston Price. So what he was doing was going around getting all these people to open their mouths up and photograph their teeth. And it is very, very interesting. And he was actually using this Activator X, which he found was largely in sort of grass-fed butterfat. He was using that with his patients and actually reports cavities healing up. Now, what a thing. I mean, if that bears out, then the dental profession has got to really look to its laurels, hasn't it? It's in trouble if we're all curing our cavities. But I think K2 may well play a part. It certainly plays a part in dental health. Does it play a part in restoring holy teeth? Maybe. I think it may play a part.
Certainly, a few people claiming that. So yeah, it's very interesting when you have families with several children. You find that the successive children have successively narrower faces. So the first child might be born with a nice broad face and a very symmetrical face, and then as time goes on and the mother has more children, it's depleting her K2 reserves, and each child is having less K2 to make the bones in the face symmetrical, and you find that children are have too many teeth for the width of their jaw, so the dentists are having to pull out teeth. You find there is some research suggesting that cleft palate is that K2 is implicated in a cleft palate.
Yeah, well, in fact, that is true in my family. So I'm the eldest of 4 children. I'm obviously having all that K2 from my mum. I'm obviously the most beautiful of all of the siblings. But it is interesting that my sisters' faces sort of get thinner. And so my youngest sister has the thinnest face. And in fact, she was born with a cleft palate. So, and she's had to have some of her teeth out. So some of my other sisters, and that sort of, it's a study of 4 people basically, but I think it does bear out what we seem to be reading about as well. Is interesting. So very important for the mother to be supplementing, with K2 for her subsequent children, I think. And that would mean, less braces and all that sort of stuff having to be used.
Yeah, and then it's really important as well, once the baby's born, to be breastfeeding and taking K2 in, so that the K2 can be given to the child as it's growing its bones and its teeth and its nervous system, because K2 is just so important for all these things in the early years. There is some question as to whether MK7 is able to cross the placenta. You may see people asking that, because MK4 is the type that we have naturally in our bodies, and that's what crosses the placenta. But in actual fact, what's happening is that MK7, a bit is getting chopped off the end so that it becomes MK4, and then it's able to go through the umbilical cord and feed the baby with all those
so supplementing with MK4 is not a really good move, because it's not very effective in the body. But MK7 hangs around a long time, and it gets converted, and we will. Okay, so vitamin K acts in lots of different places, and there's some amazing studies about this stuff. There's one, if you look down the bottom, the Rotterdam study, so 4,800 people. This is a kind of held up in the vitamin K community as being one of the huge things, but it's so significant. So you've got a 10-year study, and supplementing 45 micrograms of K2 unbelievably reduced cardiovascular mortality by 50%. That's huge. Yeah, we put 180 in ours. In fact, there's 60 in the Cell Centrals. So it isn't very much at all. So reduce cardiovascular mortality by 50%, reduce risk of dying by 25% over this 10-year period. So absolutely huge. There's another study called the EPIC study, which was published in the British Medical Journal of 2013. And that was showing for every 10 microgram increase of K2, a 9% reduction in cardiovascular mortality. It's huge. So what's going on here? I mean, the other thing to say here is that we said at the beginning, single nutrients don't work singly. And I think the problem with medicine getting involved in nutrition, they know about allopathic medicine, so they know about pharmacology, they know how drugs work in the body, but unless you're fairly clued up in this area, I think there's a risk of doing more harm than good. So one thing that's prescribed very much by the medical profession now is a combination of calcium and vitamin D. Not very much vitamin D, but tons of calcium, and that tends to be the general formula. Now, what would happen there with calcium is the body takes that in. Vitamin D helps that to be absorbed out of the gut, but what happens after that? Because calcium can then go into the arteries, it can go into your soft tissues, it can go around your nerves, it can go all over the place. And where we want it is in our bones. So what vitamin K does is basically it acts as a stimulator to turn on these proteins so vitamin D sort of signals these proteins to be made, but they're made in an inactive way. And what vitamin K does is then to turn these proteins on. So once you've got this protein turned on, in terms of cardiovascular health, this protein is called matrix GLA protein, and it signals the body to remove calcium out of the arteries. Now, if you look at, reverses arterial stiffness, for example, if you look at the correlators between why people have heart attacks, we look at things like cholesterol levels, and we look at blood pressure, and we look at stress hormone markers and things like that. But it's only a fairly inaccurate marker, i.e. half the people who have heart attacks have normal cholesterol, and half the people who have heart attacks have normal blood pressure. But 100% of the people who have heart attacks have calcified arteries, and it is the best correlator. So as it says there, if you've got an extra gram of calcium a day, if you just think what calcium is, and it's basically a stick of chalk. If you eat a load of chalk, you're depositing a load of mineral, and it needs to know where to go. So an extra gram of calcium a day doubles the risk of heart disease. If you do that again and you're taking 2 grams extra, you're quadrupling your risk of heart disease. So I've seen a lot of these formulas that are prescribed, and they're 1,500 milligrams of calcium. Now, I'm not saying we don't need calcium, because we do, but we need it to be balanced with magnesium and vitamin K and boron and vitamin C and all these other things that mean that if you're going to just self-prescribe things like this, you're going down a dangerous road, because you can be doing more harm than good. So I hope that sort of makes that clear. Yeah, and that's why kind of we, for a start, why we rely on somebody like a company like USANA, because they've got 85 scientists looking at this all the time, and 18 PhDs or something. So that's what they're doing, is evaluating all this risk-reward ratio. And unless you've got that, it can be a bit of a dangerous area.
I think it's interesting also to say that matrix GLA protein is the only thing that transports calcium out of the arteries. So so then we get onto bone health, because the two really go hand in hand, and you might be going to the doctor, the doctor's worried about your bone density, and they prescribe you this AdCal, which is calcium carbonate, which is basically, as David says, chalk, and vitamin D. And why are they prescribing vitamin D with calcium? Because they have this little bit of knowledge that vitamin D helps the gut to absorb calcium.
Which it does.
Which it does, it's quite true. But in fact, we may even be getting plenty of calcium in the diet. We may not need to add calcium in supplement form, or certainly not in this high dosage. The problem is that calcium isn't being put in the right places. So how does it get put in the right places? Well, one of these another of these proteins, like matrix GLA, which is produced by vitamin D, or sort of stimulated to be produced by vitamin D. It's switched on by vitamin K2, and this second protein is called osteocalcin, and osteocalcin is like the glue that sticks calcium into your bones. So you might go for a bone mineral density scan, a DEXA scan, and they might find that your bone mineral density is actually okay. You know, that they might, yeah, you might come away finding that it's okay, but what they're not picking up on is that the calcium may be deposited just around the outside of the bone, and on the inside there's basically nothing much there. So it's very, very brittle and very flimsy on the inside, and what you need is not this outer structure of calcium, but a very solid structure, like a honeycomb structure. And they've actually found that when people have calcium deposited in their arteries, that calcium is being deposited in a honeycomb structure. So really, the arteries are turning into bones, which is a pretty scary thought. But then back to real bones. So we need this osteocalcin to be activated by K2 so that it can stick the calcium right into the heart of the bones, right into where it should be, and not just a layer on the outside. But also what the doctors are not really taking into consideration is that bones are not just about calcium. They're about so many nutrients, like about 24 nutrients, I think, are involved in bone building, including magnesium and phosphorus and boron and silicon and strontium and all, and not least K2.
Yeah, if you DEXA scanned a stick of chalk, it would do really well. But
Yes.
you don't want a femur that's made of a stick of chalk, because it's just going to crumble.
Yeah.
So
who have the best outcomes for bone health? Well, it's these people in Eastern Japan who eat natto, and there are various studies on the correlation, and they've found that it's an absolute watertight correlation between your levels of K2 and your risk of hip fracture, and also your risk for cardiovascular disease and heart disease. So Eastern Japan, they're eating natto. Western Japan, they're a bit more trendy. The Tokyo dwellers, they think eating natto is a bit of a disgusting peasant-like thing to do, so they don't touch it with a chopstick. In the UK, they find that...
You mean Hiroshima, but yeah. Yeah, Tokyo's on the east, isn't it?
Yeah, so no, Tokyo's where they're not eating natto.
Oh, I thought it was somewhere around. Okay, well, we'll agree to disagree.
Well,
but anyway,
you could be right. But anyway, in the Eastern Japan, they're eating lots of natto. In Western Japan, they're not eating any. And East has very low rates of hip fracture compared to the West. And then you get to the UK, where we have absolutely massive rates of hip fracture, and osteoporosis is epidemic, at epidemic levels. And what's our intake of K2? Well, it's absolutely minimal.
Yeah.
And then we get on to, so this metabolic health, osteocalcin, that clever protein that puts calcium into bones, is also somehow involved in insulin metabolism. And they're not quite sure why or how, but there's lots of osteocalcin in the pancreas, which is where insulin is made. And there are various studies on the correlations between K2 and metabolic health. This study with 38,000 people showed this massive risk reduction for every 10 micrograms of K2 in the diet or in supplementation. showed a 7% risk reduction for type 2 diabetes. And then there was this other study at Tufts University. They split the research group into 2 groups. One was not supplementing with K2 and one was supplementing. And the one that was supplementing with K2, 80% of those people went on to develop diabetes, whereas 78% of the ones who did supplement didn't develop diabetes. So that's a pretty clear correlation. And then, so you've got heart disease, you've got osteoporosis, you've got type 2 diabetes. I think with those 3 things, that's probably about 75% of the healthcare budget. And then if you add in cancer, you're getting to about 90% of the healthcare budget. There was this study called the German study, 23,000 people, found an extremely strong correlation between levels of K2 and cancer. So the more K2 you have, the less cancer incidence they found. And then there was the Heidelberg cohort study, 11,000 men or so, a 35% reduction in prostate cancer was found with the men with the highest levels of K2.
And then you've got these other diseases linked. So cancer is an inflammatory disease. I mean, one of the things that is found about K2 is it sensitizes, or it reduces the activity of a thing called interleukin-6, IL-6, which some people have a genetic weakness with. But if they take K2, that should switch that, or turn that down, basically. And that would be true not just of cancer, but of anything that's inflammatory. Anything with an itis, by definition, is inflammatory. So you've got all these other things that K2 very, very likely plays a part in. And it's still an unfolding story. And the leading researchers, one guy that I've been watching a lot is a guy called Kiran Krishnan. I think he's amazing. He probably knows more about K2 than almost anyone else on the planet. But he reckons we're only still at about 15% of the knowledge that will unfold over the next, say, 10, 15, 20 years. So
I think we've been saying, oh, what about such and such? Let's look up, see if there's a study about K2 and whatever, you name it. And there is, we've found so many studies that we're not even going to touch on here because we don't have time.
Okay, so one interesting thing is, if you don't care about osteoporosis yet, or cardiovascular disease, or cancer, or diabetes, or whatever, you might be a 20-year-old athlete watching tonight. I don't know. So if you are, or if you think you want more energy, then really K2 is where it's at, and this is absolutely huge. So K2 has loads of. We've been talking about that tail a little bit, where if you've got 4 units and it's an MK4, and MK7 has 7 units on its tail. But central to K2 is it has a quinone ring. So a lot of you will have heard of coenzyme Q10, which is also called coquinone or ubiquinone, and that also has a quinone ring. And it's involved in the electron transport chain. It's involved in basically how we make energy. And one thing that can happen is that chain can get blocked up with calcium. And what K2 seems to be able to do is to bypass that if there's a problem. So that's sort of the biochemistry of it. But the effect of that is that then we can improve, or what the studies are showing. There's a guy called Harry Rossiter at Leeds Biomedical Sciences. He's a professor up there, and they've been doing some research on energy production in athletes, and it's phenomenal. It's phenomenal. So we've put some of it on there. 12% increase in cardiac output. So you're getting an extra 60 liters of oxygen every hour around your body. And this study that I'm sort of telling you about now, what they did was they put people on 300 micrograms of vitamin K2 for 4 weeks, and then 150 for the subsequent 4 weeks. And the result was that it was equivalent to these athletes having done 6 months of high intensity cardiovascular training. So I've got a friend he was sort of overseeing the is in charge of UK Olympics, basically, and in charge of sports performance for UK athletics. And he was telling me about the preparations that go into preparing an Olympic athlete to be an Olympic athlete, from being a sort of normal athlete to being world class. And he said it's 4 to 10 years usually. So this study showed that you can get the same effect in 60% less time. Now, whether that pans out to a whole Olympic preparation, I don't know, but nevertheless, that's a phenomenal result. So if you could take that 10-year preparation and make it 5 years, that is just amazing. And it also has implications for, obviously, for exercise, for recovery from training, and yeah, absolutely huge. So not to be ignored. And I think it looks like it's got a greater potential there than coenzyme Q10 actually, which is saying something, because that's one of the sort of held up things for sports performance and exercise.
Yes, and now we're going into the more sort of off the wall benefits. So there's, just as we mentioned just a minute ago, there's tons of research. So we're just going to pick out a few. I mean, we're all interested in COVID-19 at the moment, or the media.
I'm not.
No, I'm not really. But there was a study done this year in the Netherlands on outcomes of people being treated for COVID-19, and they found that the more K2 that those people had in their blood, the better the outcomes, the better the COVID-19 outcomes. And what they thought, which is why I'm why we've linked this to COPD, which is a lung disease. The suggestion by these researchers is that K2, which is an actual fact, that K2 prevents the breakdown of elastin, and elastin is not only involved in the skin, which is why we've got wrinkles there next down. It's also involved in the structure of the lungs and keeping the lungs intact. And I think that's one of the things with COVID-19, where the lungs seem to lose their integrity, and they seem to lose their structure. So if that elastin is not breaking down, the lungs are managing to stay healthy. Wrinkles, you've got the elastin picture, but you've also got calcium in that picture, because deposition of calcium in the skin can cause the skin to be more rigid and less flexible, and that's how, that contributes also to wrinkles.
Yeah, that's basically what K2 is doing. It's just not able to send the right messages. So as Angela was saying earlier, you can get arterial cells that are supposed to be nice and flexible, and the message they're getting is be a bone, and they're turning into bone cells because they're getting confused messages basically. Yeah. So then I sort of mentioned the inflammation thing as well with interleukin 6, and it also dampens down nuclear factor kappa beta. I mean, these are all big things, and then enhances the immune system by turning on some of the functions of the immune cells. Then we've got beyond that, as I put there, mitochondrial issues. So these are a lot of the diseases we suffer from, like Parkinson's and multiple sclerosis. They are to do with the mitochondria not working properly. And where I said in that electron transport chain where it's getting bunged up with calcium, that's what we're finding as part of the reason for that. Part of the protection that K2, again, we've got nerves, obviously, hopefully, running all through our bodies, and those nerves are protected by a fatty sheath. It's a myelin sheath, which is sort of stopping those nerves from misfunctioning, and K2 helps stop the prevention of the myelin sheath.
It stops the damage to that.
Eye health as well, and brain health. So I have to say with eye health and brain health, I mean, we need fat. We need fat, because where are these fat soluble vitamins coming from? They're in fat, aren't they? So vitamin A, D, E, K, they're all things that we're learning more and more about. We need certainly more D than we thought 20 years ago. We need a lot more K than we ever have known about. Vitamin A is the only thing that really has the possibility of toxicity, and vitamin E we certainly need a lot more than we get from our diet. But what we're finding with these 4 fat soluble vitamins is they need to be in a certain ratio. If you got too much of one, you have too little of another. It sort of upsets the balance of them. So again, that's about, as we said at the beginning, don't just go and buy K2, although it has many, many benefits, but the benefit comes from the synergy, and that's always going to be the case. It's always going to be the case.
Yeah. The other thing about eye health is that I think it's maybe commonly accepted that eye health deteriorates when you've got fatty streaks in the arteries. But what's actually going on there is the focus really shouldn't be on the fat. It should be on the calcium, because the calcium and they're tiny blood vessels that go to the eye that need to be clear in order to feed the eye with blood. But if these tiny blood vessels are getting clogged up with calcium, that's obviously going to damage your eyesight.
Yeah, and that's a big process, that calcium clogging, and it starts with irritation as well, and it starts with too much oxidative stress in, as Angela said, very small sensitive tissues, so you can do a lot of damage very easily there. So yeah, just say something about muscle cramping, because you're the expert on it.
Well, there was they've done some research on muscle cramping and relaxation of muscles. So they've stretched a muscle between two pegs, if you like, and put in certain toxins that make the muscle cramp up, and then they've added K2 and found that the K2 relaxes the muscle again, which is amazing to know for people who suffer from cramps. But they've also tested it with adrenaline. So they've cramped the muscle up with adrenaline, which is what you want to happen when you're running away from, if you're running away from a tiger, or if you're trying to get out of the way of a car that's about to crash into you. You need that surge of adrenaline, so you don't want your muscles to suddenly then relax. But they found with K2 that doesn't actually have the relaxation effect on a muscle that's been activated by adrenaline. So that's very interesting.
Yeah, and so in anti-aging, one of the studies we looked at showed a 7% increase in life expectancy.
7 years.
So it was 7 years.
Yeah,
okay, sorry, 7 year increase. And again, down to the suppression of these inflammatory factors, inflammatory markers, and also vitamin. As if vitamin K can't do enough, it also acts as an antioxidant, and not only just a little one. It's actually, they think, 10 to 100 times more powerful as an antioxidant than many of the things that we hold up as sort of benchmark antioxidants. So it has that function as well. And if you're not convinced by now,
And the last thing, liver health, that quite often, I think, or it can happen that hepatitis then develops into cancer, but they have found that K2 has a protective effect on the liver and prevents that progression into cancer. That's what some of the studies are showing.
So some of you may have heard of a thing called the French paradox, which was, that thing has been around for 30 years or more, and people have been talking. The French paradox is basically, how come the French eat all this fatty food and don't have much heart disease, or compared with us anyway? And the theory has always been, they drink all this fantastic wine, and this fantastic wine has resveratrol, and which comes from grapes. And I'm not knocking resveratrol, because resveratrol is fantastic. It's a brilliant, it actually forms part of USANA's cell signaling complex that they won that patent for, which almost allows them to say you live longer if you take it. So I'm not knocking resveratrol, but I think what probably is the case with the French paradox, what they're doing is they're eating fermented cheeses, and their cows are fed on grass, basically, and their butter is coming from cows that are fed on grass. So in other words, here we are again, we're back at the the K2 being at the center of this picture. So lots of saturated fat, because that's where the K2 is, but it's good quality saturated fat. So it's come from the right place in the first place. And one of the big researchers in this area is a woman called Kate Bleu. She's Canadian, and she said, if you want a healthy snack of an evening, get some fermented cheese and a glass of red wine, and you couldn't do much better. So so there we are. We've probably got the French paradox is probably both those things, but I'd say the K2 is playing a bigger part actually from what we're reading. So what reduces or increases the needs for K2 in the body? One thing, again, not supposed to give you medical advice, and we're not trying to, but we will say that, for instance, the statins that are very widely prescribed, and if you want to hear more about that and my opinions on that, then I've got another talk on metabolic syndrome where I go into that in quite some depth. But basically, in this case, the statins that are prescribed all the time to reduce cholesterol, remember I said that that's not a very clear marker of heart disease anyway, and there's an inverse correlation between levels of cholesterol in the body and development of Alzheimer's. So you actually want, for instance, because cholesterol is in your brain, you don't want your brain to stop working. So you don't want things that are going to reduce cholesterol, really, in my opinion. Anyway,
you also need cholesterol to activate vitamin D, which is...
Yes, indeed. Yeah. So it's all part of that picture. So what do statins do? One of the things they do is you can use K2 sort of 4 or 5 or 6 times in the body. It goes around this site. It's recycled by other things which make up enzymes. And we're back at the cell essentials argument. We need all the other bits as well to do this recycling bit. What statins do, though, is they turn this recycling process off. So it gets used once. So you might be taking 100 micrograms of K2, but it's only effectively 20 because you've got the statin interfering with it. And then you've got other things which, well, there are some more modern things like Xarelto, which are prescribed for reducing your incidence of blood clotting, rather than warfarin now so much. But warfarin interferes with K2, and I think that causes a lot of problems. So we're prescribing things for heart health, but actually interfering with heart health, because if you X-ray someone that's been taking warfarin, you can see their arteries really clearly on the X-ray. And why can you see them really clearly? Because they're bunged up with calcium. So they've got a really clear outline. And that's because the K2 is basically being switched off by the warfarin. So this matrix GLA protein is just not working anymore. And you get this accumulation of arteries and of calcium in the arteries. And now you've got a 100% correlation between calcification of the arteries and your risk of heart disease.
Yeah, and then you get into antacids, which are prescribed for high stomach acid, which can be important. An antacid for a short period can be an important thing to do. But long term, they really deplete the absorption of a number of minerals and micronutrients. And one of those micronutrients is K2. Other ones are zinc and iron and B12. Also antibiotics, they're going to be killing all the bacteria in your gut, not just the bad stuff or the unhelpful bacteria, but also the good bacteria. And some of that bacteria is going to be making K2 and converting K1 to K2. So if you're getting rid of all that, then that's one whole area where you're not going to get it, and your helpful bacteria are not going to be fed either. Gastrointestinal problems, so if you've got absorption problems, if you've got inflammation in the gut, that's going to reduce your absorption. So there, in that case, you might want to increase your intake of K2. And then you've got this thing called dihydrophil. Oh, what's it called?
Dihydrophilquinone.
Oh, I nearly got there.
Yeah.
In junk food, so it's a quinone, but it's actually the evil guy in the quinone family.
The evil twin sister.
Yes.
Yeah.
And it absolutely, it just turns off K2, it turns off MK7. And you have a much higher risk of heart disease and all those other things that we've been talking about if you're eating junk food.
Yeah. Okay, so we're just on the last few slides now, I think. So I've mentioned synergy already, and I mentioned the limitations of just using calcium and vitamin D. I would also say, I mean, there's some other things that we need to talk about a little bit as well. We've talked about vitamin D signaling these proteins to be made, and then K2 switching those proteins into an active state. And vitamin A and D, again, another fat-soluble pair, works synergistically. When we're looking at the ratios of these things, it's really important to get those things right, and hence, again, where we put our trust in the huge scientific resources that we're lucky to be connected with, I suppose, in terms of USANA. But there's also problems with stability of products as well. So where you've got vitamin D and vitamin K do work together, I mean, there are some things on the market like vitamin K and D sprays, but they're not very stable. They have to put a lot of preservatives in those things to stabilize them, but they don't stay stable very long. One of the things about vitamin K is when you combine it with something else, it actually destabilizes that molecule quite quickly. So you've got a danger with those things, especially the sprays. I think liquids are not a very good medium for delivering vitamins, but it's the stability issue and the interaction issue which is the problem. So I think having a vitamin K product on its own is actually a really sensible move, actually.
Mm-hmm. Yeah, then you've got the energy production. We talked about the role of K2 in the mitochondria and helping with energy, but what are the synergies going on there? If you're putting in K2 and hoping to get more energy out of it, that's only a little bit of the picture, really, because you've got so many nutrients that this Krebs cycle, as it's called, which is the chemical process in the mitochondria that are creating ATP, which is the body's energy currency. So this cycle, what's it dependent on? Calcium, magnesium, B3, B6, B5, B1, B12, biotin. So, if you haven't got good levels of these things, and then you've got the electron transport chain as well, which is part of the mitochondrial process or the energy making process. You need iron for that, and CoQ10 and copper. So you've got to make sure that you have very finely balanced levels of all these nutrients. And if you put in a high level of one nutrient, you are going to upset all the other ones. And, research scientists spend their whole lives looking at this stuff. So we cannot presume that we know what to do and just go out and buy a pot of magnesium and B12.
Yeah, I often challenge people in my talks to memorize this diagram, but if you really know this diagram, then I'm going to let you off, but otherwise let the scientists handle it, basically. So then we come to how much we need, and I think we're probably on about the last slide, or pretty much. So we've talked about sort of MK4 and MK7. They're the things that are the most studied. But if you look at this, I think there's a very clear winner. Vitamin K7, MK7 is vitamin K2, MK7 is the one that's the winner. So, and here we're talking about stability. I mentioned it before, but what USANA does is make sure when they produce something, they test it right up until the label expiration date to test that it's still fully stable, and they actually do test beyond that as well.
It's 100% guaranteed to be stable up to the use by date.
So do you want to just say something about this?
So if you look at these two charts, you've got the MK7 is in green and the MK4 is in red, and you can see from these that MK7 stays in the body a lot longer, so it's called the half-life, has a much longer half-life in the body. But MK7, as we've mentioned, is converted into MK4 anyway, and is then used by the body as needed.
Yeah. Okay, so here we go on sort of this triage system, which was the baby of a guy called Bruce Ames, very famous biochemist and nutritional guru. And he came up with this triage theory, which is basically saying you're going to do the most important things first. The body is going to do the most important things first. So when I said near the beginning about the first thing you need vitamin K2 is to stop you bleeding to death, that is the first thing that goes on with the K story. Mm-hmm. The next thing, if that's covered, is that then you don't want to have a heart attack. So you're then the first 40 or 50 micrograms of MK7 after that go towards turning on that MGP protein, which gets the calcium cleared out of the arteries. And they found a higher level than that actually reversed arterial stiffness. So this is where I'm saying it can be not just preventative, but interventional. And beyond that, we're then looking at the activation of osteocalcin, as Angela described, with laying down that calcium where it should be in the bones. Beyond that, we're talking about long-term nerve health, inflammatory health, and reducing the risks of multiple sclerosis and Parkinson's and Alzheimer's and things like that. Then, once you've got all that covered, because if you think about the first one, we want to be able to bear children before. We don't want to bleed to death, that's number one. We then want to be able to bear children. Then we want to not break our bones and need to be cared by other people. Then doesn't really matter so much in evolutionary terms if we go a little bit doolally when we're older, but actually, because we're not bearing children anymore, we're not producing children anymore, but we actually want to hang on to that health as well. And that level, we're talking about 180 micrograms, kind of, if you've got all that sorted out, then the extra bit goes into the sports performance and performing at an absolutely optimal level. And that level seems to be somewhere between 300 and 350 micrograms, somewhere around there. And I've been fascinated by, it was a study that was done quite a long time ago. It was published in the New Scientist, and they looked at these athletes. Well, it's looking back at ancient Greece, and the story goes that the Athenians were going to persecute this race because they were trying to quell an uprising, basically, and they sent off this trireme, this boat, to go and kill all these people. And then the king or whatever had a change of heart, and he said, actually, no, let's not kill them. They're not such a bad bunch. So they sent off another boat to catch the first boat. And they've reproduced this study. They've actually rebuilt these triremes, and they've put elite athletes in there.
So they're rowing.
They're rowing. Sorry, I didn't mention that. They weren't flying. They were rowing. And they've worked out how fast these rowers were going. And they reckon that our modern day Olympic athletes could not keep up with them. Now, I reckon, he has his own theories about this. I reckon that the ancient peoples, especially in Greece, where they've got loads of sort of grass-fed stuff, and they've got loads of high omega-3s in the grass and hence in the whole food chain, but they've also got high K2. And I reckon these kind of, let's say, normal people were able to function more like elite athletes. And what does that spell for our sports performance as this research unfolds over the next 10 or 15 years? I would predict a lot of Olympic records are going to go as we discover more about the enhancement in performance of these quinones. So I think it's a really exciting area of research, not just for health and longevity, but for maximizing our body's potential as well.
Absolutely.
So in terms of USANA, because a lot of you on here are involved with USANA, we, as I said, we have 60 micrograms in the cell centrals if you take them at full dose. A lot of people take an extra D tablet from America, which has an extra 30 micrograms. So now we've got 90. This is 180 micrograms in this K2 product. So now we're at 270. I would take sort of one of these a day, and I have been doing for a while now because I just think it's so important. And then every so often I just take a couple. And that way, the half-life of vitamin K2 is 3.5 days. So you don't have to keep sort of topping it up all the time. But I just take, every so often, I just take an extra one. And I think I'm aiming to bring my average up to kind of somewhere in the 300, 350 range. And that's what I recommend,
Yeah. So then that just brings
Last
us,
slide, thank you.
Yeah, where do you go from here if you want to know more? Well, this book by Kate Rayon Bleu, who David mentioned earlier, is probably the place that we would start. It's absolutely amazing, comprehensive book about the subject. Then a lot of you will be familiar with this comparative guide to nutritional supplements. There's a really great chapter in there on K2. And then any videos that you can find by this researcher, Dr. Kiran Krishnan, are superb.
He's all over YouTube, so you'll find lots of stuff. Yeah, he's fascinating.
Yeah.
Not as fascinating as us, but quite fascinating.
And then, if you're in Usana, you'll have heard of this Dr. Ladd McNamara. He has a webinar on the Patty Roney health webinars page, which is very informative.
Yeah, that was really interesting, his webinar.
Yeah, so that's it from us. And
you might have heard enough about K2, but I would definitely incorporate it in your regimen, or just go and ferment some soybeans and make your own natto, and then you're covered, because then you're getting 600 or 700 micrograms a day anyway. But you'll have to stomach the smell and the taste of it. So.
Yeah, you might get used to it.
Yeah. Okay, so basically it's a big thank you from us for tuning in. We went on a little bit longer than we intended to, so sorry about that. I noticed we got quite a lot in the chat, so let's just see if we've got any questions. But if you plan to just disappear now, then again, thanks for tuning in and really appreciate it. So for you guys, it's Geek Corner, Nerd Central signing out for the evening, and we'll go and have a look at these questions. Okay, there's a lot of them.
Yes.
Oh, sorry. Right, let's go back to the beginning. Okay.
Thinking Bishop.
Hi, Anna.
Hi, no, then a question. We were laughing when you were talking about the shape of the face, and Cherry said, "Oh, wonderful."
Yeah, I'm not sure. I don't think there's probably much K2 in Stinking Bishop. That was just comparing the smell.
Yeah, yeah. That's interesting. Sharon said
loads of
privately.
Yeah.
Yeah.
Sibling number 4.
And the most humble. Thanks, Alex. I trust you to pick up on that. Yeah. I can't help it if I'm orders. Is K2 in the
baby care?
Is K2 in the baby care?
Baby care, as in the
children's microvits,
or prenatal essentials? Do you mean?
Oh, in the prenatals. Let me just go and have a look. You can sift through some questions.
Oh, Cherry says yes.
Oh, okay.
She's answered it.
Oh, okay, great.
So. Does Magnacal D have the K?
No.
No, it doesn't. Agnes takes 6,000 milligrams of Adcal every day because of my thyroid cancer history. I was worried of this too much intake of this chalky substance. This is heaven-sent information for me. Osteopenia, yeah, exactly the same.
I'd say that's
Joanna.
it's a bad move. Loads of calcium with cancer. That's not.
No, it's not a good thing. Yes, Joanna, osteopenia is, same principle. Are you going to tell us what natto is? No, I thought we did.
It's right at the end.
Yeah, it's fermented soybeans. I think I said that in my second slide. Somebody said we did. K2 reduces the risk of inflammatory diseases. Yes, it does. Did they give K2 to Trump? Does it have any contraindications with other drugs? Well, there's that whole thing about warfarin and whether it
There is, I
increases-
mean, that's a subject perhaps for a private conversation,
yeah.
because you've got that book of
Yeah.
nutrient drug interactions and stuff. So
Yeah, you need to be talking to health professionals about that. I mean, you're welcome to
you're welcome to contact us if you've got any specific questions, for sure.
Does K2 need to be balanced with other nutrients? Well, I think we've covered that
We
one.
covered that, yeah.
Can it be taken with other USANA supplements?
It should be.
Should be, yes.
Yeah. Yeah, correct. Cherry, correct.
Calcium, vitamin C helps stop cramps. Mm-hmm. Lots of wrinkles, comments, or antacids, or just the PPA. Well, anything that reduces your stomach acid is basically going to also reduce your nutrient absorption.
Yeah, statin's getting another knock.
Yeah,
which I think they need.
Refuse to take omeprazole. Do take Gaviscon. Yes, well, I think all these things have other problems associated with them. Look after grandkids.
Yeah.
How much? 6,000 milligrams of Adcal. How much K2 do I need to take?
You're getting, well, Adcal's got 400 IUs of D, so you're getting 1,600. So you probably need 160. It's about a 10-to-1 ratio, 160 micrograms of K2. But I just wouldn't take that much calcium. That's not good, not good. When we're looking at why mitochondria go wrong, they go wrong because they clog up with calcium. And also your arteries are going to clog up with, everything's going to clog up with calcium. I think that's no. Yeah. Not
medical advice, but
no.
That's why David hasn't got wrinkles.
Yeah, I'm only 23, Cherry. K3. Well, there is a K3. There is a K3. It's
synthetic.
Yeah, it's
actually been
poisonous.
Banned by the Fed. The not the Fed. The
European Health Authority, or whatever it is.
The FDA is what I was thinking.
Yeah, it's fed to animals, so you've got to be a bit careful. But what's it called? Metadione or something? Can't remember. Thanks, James.
Thank you, James.
Cheers,
thanks,
Alex.
Alex.
Thank you.